think I was just rushing on in the first part, but that's fine. I can always re-explain. In terms of re-explaining, I mean, by the formula, you don't really need to write your formula down. You can just go and substitute directly because this is mathematics. You're not really marked for your formula. Anyway, they already give you the formula sheet. Well, they still do even in science, but math is different. So that's why you don't see me writing formulae for gradient for the midpoint as well. But it's very wise for you to write them. So let's solve for x and then I can show you the formulae afterwards. Well, at least for reversing the midpoint. So if we consider this equation, we can see that the denominators are the same, right? Okay. In the laws of exponents, we know that if the bases are the same, we equate the exponents. But in the cases of equations involving fractions, if the denominators are the same, then we equate the numerators. It works all the time. You don't need to cross multiply or do anything. So you say 3 is equal to negative 3 plus x, which means that the value of x will just be 6. Now, what about here? Well, here the denominators are not the same. So you have to cross multiply or multiply by the LCD. So we take the numerator and multiply it with the denominator. And so on the left-hand side, we have 4 plus y. On the right-hand side, we have negative 4. Well, this means that our y has to be negative 8. So now we know the x coordinate, we know the y coordinate. Now we can conclude and say, well, this means the coordinates of the point F will simply be 6 and negative 8. And it fits because this is the x value of 5 and F is definitely at a point that is greater than 5. So yes, what I'm saying to you is if they tell you that a figure is a parallelogram and they ask you to find the coordinates of one of the vertices, it's very easy if you use the midpoint property of the parallelograms. Use the fact that the diagonals bisect each other. It's the easiest in business. Yes. Find the midpoint of those two diagonals using one of the diagonals, which we did here. And then now that you know those coordinates, then you can consider another diagonal and reverse the midpoint formula. Because according to this, or rather, what can I say? I think I want to say, if you are now reversing it, you say the x coordinate of the midpoint is going to be the x coordinate of the point A plus the x coordinate of the point F divided by 2. That's how you reverse it. And this is your x coordinate of the midpoint. And of course, for A and F, you know those x coordinates, which is what we did here. So, yes, So I think it's a little bit scary if you first look at this mark allocation, but it's not. So here they say, please calculate the size of angle EDO correct to 1 decimal place. EDO, where is this EDO? Well, if we go to our sketch and try to clear it so as to see this clearly, well, this is E, this is D, and this is O. And when they ask you for an angle, naturally, you want to think about Euclidean geometry, right? You want to think about exterior angle of a triangle, sum of interior angles, and things like that. You naturally want to think of that. And furthermore, you know that the entire figure is a parallelogram. Those are the things you naturally want to think about. But then in analytical geometry, I actually need you to know that for angles, we primarily use the inclination of lines. That's the primary tool that we use in order to find an angle, which is why I drew this diagram for you. And this horizontal red line that you see is a line that I want you to construct in the exam, okay? Because it's really going to help you to be able to see these things clearly. What am I saying? Why do I need to have this red line anyway? We are looking for this angle, EDO, is it? Of course it is. So this is what I'm saying to you. You go to this vertex, the point D there, and you draw your horizontal line. And I want you to see the significance of this. It's because we know that the inclination of a line, as Riatlehide has told us, it's the angle between the x-axis, the horizontal plane, and the line. So what am I saying? I'm saying to you, if you were to calculate the angle of inclination of this blue line, and you come back and you calculate the angle of inclination of this pink line, and you find the difference between those two angles of inclination. By difference, I mean the bigger angle minus the smaller angle, then you get your EDO. Do you see that? It's very wise for you to draw your horizontal line. You'll see it in the other question that follows from this one as well. I mean, a separate question. But then from this sketch, we see that this is the x-axis, this is the x-axis. And those two x-axis or horizontal lines are parallel to each other, which stands to reason that the inclination of the blue line is actually the beta, which was given to us in the original statement. And similarly, the inclination of this pink line is just going to be alpha, which was given to us. So what I'm trying to tell you here is the angle EDO is just going to be alpha minus beta. Over and out. So seeing what we see, then we can easily go ahead and destroy it. So let's do that. So the question is, EDO, do we know the gradient of AD? No, we don't. But then we know the gradient of BC because the first question said we need to calculate the gradient of BC. And I think we found it as -8. Please correct me if I'm wrong, but I think it's like that. So now we are going to come back and go to this AD. So what do you say when we get to AD? Let's use black for once. Well, this is how the inclination of the line is defined. So we say the tangent of alpha is equal to the gradient of AD. But then remember, AD is parallel to BC. Why? Because they told us originally that ABCD is a parallelogram. So those are the opposite sides of a parallelogram. So we know that they have the same gradient. All right? So this means the tangent of alpha will be equal to the gradient of BC, which is -8, as we got it in the first question. Now, in order for us to find alpha, We just need to find the arctangent of -8. But then you're going to get a negative answer when you say the arctangent of that. So it's -82. Well, right away we can take it to one decimal place. It won't affect the final answer. But since it is negative, we have to add 180 degrees always. You don't need to worry about the quadrants. This is not trigonometry. This is analytical geometry. So we just add 180 and we get away. Then, of course, if you add your 180 to 82, you simply get 97.1 degrees. This is the size of angle alpha. Then we come back and we go to this BD, okay? Now, once again, we know that the gradient of BD because we found it as the gradient of BP. Do you remember that? When we used the origin as well as the point B, and we got it as 2. So here we say the tangent of beta is just going to be the gradient of BD. Yes, we can say that. So this means the tangent of beta is going to be 2. So beta is the arctangent of 2. And if you now press this into your calculator, well, you say it's the arctangent of 2, which is just 63.4 to one decimal place. So now that we know those two inclinations, well, it's now very easy. We can say EDO. It's just going to be alpha minus beta, which is 97.1 degrees minus 63.4 degrees. And I'm not sure if they would mark you wrong, but I know that if I was the examiner, I was going to mark you wrong if you forget your degrees. So many of you forget your degrees and you just say 97.1. Please do things the right way. If they mark you wrong, they don't hate you. They want you to do things the right way. So yes, this is just going to be the size of angle EDO. Then the last one says, let's calculate the area of triangle ADC. I know these are the last questions. The last questions are always challenging, especially in analytical geometry. And those ones of areas, yes, I know that it's the questions that don't really give us the time of day, but they're not really bad, not bad at all. No, not by a long shot. If you're able to find your angle as well as I don't know, but they're not bad, not bad at all. No, 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 no. So how can we find this area of triangle ADC? Well, it's really easy. Where is this triangle anyway? ADC. Well, this is our A, this is our D, and of course, this is our C. Okay, it's not that. It's ADC like this, right? Well, the question is this a right-angled triangle? No, it's not. How do we know it's not? That's a good question. Well, we can quickly check if it is indeed a right-angled or not. How? Well, we already know the size of this angle. Okay, this is what I want to say. I want to say this angle is the one that is in a triangle, right? And how can we find that angle? That's a really good question. Well, based on the information that we have already, it's not enough for us to be able to find angle ADC. So how can we find it? Well, we still need to know what is the inclination of the line CD. Because if we can find the inclination of CD, then we can now say alpha minus the inclination of CD will give us the angle ADC. I hope you get what I'm saying to you. And then if we find that the angle is not really right angled, which I don't really count on, then we can now safely say, well, we just need to find this side as well as that side and use the area rule. Yes, that's what I'm saying to you. So let's go ahead and find the inclination of CD. So what can we call the inclination of CD, because it's not really given to us? Well, if it's not given to us, then we can let it to be something, because they didn't mark it for us on the diagram. No, they didn't. So we can let. So we can say, let the inclination of CD to be maybe theta, because theta is not there in the original diagram. And now it's time for us to find the gradient of CD. Have we not found the gradient of CD before? AB, no, we haven't. No, we haven't. Wow, that's a shock. But nevertheless, so we can find the gradient of CD, or maybe we can find it inside of the formula and say the tangent of theta is just going to be the gradient of CD. But then how do we find the gradient of CD? Well, we take the y value at C, which is 0, minus the y value at D, x value at C, which is 5, minus the x value at D. Then what are we going to have? Well, we have 4 in the numerator, and in the denominator we have 7. So this means the gradient is going to be 4 over 7. Just to quickly double check, I don't really trust my mental maths, right? And then of course we can find the arctangent on both sides. And then of course we can now say 29.7 degrees. Let's say to 1 decimal place, consistency. So now we know the value of theta, and if we go to this diagram, we can now say alpha, which is the entire thing, minus the theta that we see here. Then it's just going to give us this angle, which is in the big triangle itself. Yes, I hope I'm not really confusing you that much. So we can now do it here actually. So we just need to get rid of this, and so our angle, what is the angle? We said it's A, and then we say it's D, then we say it's C, right? It's just going to be alpha, and then we say minus theta. And our alpha, I think we said it's 90 something, 97.1 minus theta, which is 29.7 degrees, like this. So now if we say 97.1 minus 29.7, Well, we simply get 67.4 degrees. So now we know the angle inside of the big triangle itself. We can forget about everyone now. So now we know this angle. And we see that it's not a right angle. So we can use half base by height when finding the area. We have to use the area rule. And in order to do that, we need to know the length of this. We need to know the length of that. Because we need to know two sides as well as an included angle. The angle between those two sides. So let's go ahead then. We want to find the length of AD. So we say, well, okay, after finding this theta, of course, you can tell them what is ADC, which we already did. We found it to be 67.4. Show them how you got your 67.4. Then now you can come and say, well, AD is just going to be the square root of what? I'm not going to write the formula. I'm substituting into it. So I say, well, it's the x value at D minus the x value at A squared. And then I say the y value at D minus the y value at A. And of course, I square this as well. So if I go to my calculator and plug in everything here, well, I find that the length of AD is just going to be square root 65. Then I come back and find the length of CD. Now, once again, it's just going to be the x value at D, which is -2, minus the x value at C, -5, y value at D, minus y value at C. So then, if we press this into the calculator, once again, we find that CD is just going to be square root 65. Then finding the area becomes easy now. We now say, well, the area is going to be what? Half of AD times CD. And then we times this by the sine of an included angle, which is ADC. So we have half of this. But of course here it's the sine of what? The angle that we found above, 67.4 degrees. Right. And if we now hand this over to the calculator, we find that our area will be 30.000 units squared. Please always say units squared. Don't just say 30. Although it's not wrong, but we really appreciate it when you recognize that the area is measured in certain units, which we don't really know in this case. Maybe centimeters, meters, or whatever. But if it's not given, please say units squared.